My name is Bamian Gobetz. A lot of my friends here just call me Bam. It's fine. Originally from the Bay Area. I've spent the last maybe 23 years very narrowly focused kind of in the storage vertical. I've worked for about 6 or 7 young companies that most of them have gone on to do pretty well. One of these was NetApp. So I was at NetApp in Santa Clara in the first office, was on the team of the first 3 tech support people at NetApp, which was a very exciting experience, and went through the hypergrowth phase of NetApp, which was pretty cool. I'll come back to that. The last 5 years, I got really interested in SDS and HCI. I went to Scale.io about 4 years ago as employee number 7. There was about 3 or 4 engineers that created that product. Very interesting SDS product, scale out, block, right? And turns out that block is fairly simple to build versus a scale out file system, for example. Like what NetApp did originally with Waffle. I mean, something like Waffle is tremendously more difficult to build than a block system. So what I have noticed in the last 4 years at working in SDS and HCI was that all the solutions, are fairly siloed, fairly, well deployed in smaller companies, in specific areas, VDI or very specific VMware environments. What jumped out at me after have worked also at Auspex as a startup company, which was before NetApp. So if you guys remember a long time ago, Mike Malcolm, Dave Hitz, James Lau left Auspex to start their own company. What I noticed was that the SDS market is obsessed with block, right? Now, some of these SDS players will provide an NFS protocol as an interface, but they're essentially still supporting VMs. In other words, look at Scale.io, Nutanix, SimpliVity, Hyperflex, Hedvig, Atlantis. Am I missing some, right? All the, what we call SDS, they all essentially support VMs. Some of them, very few support Linux, but none of them do distributed file system or file services. So no file sharing, no million files, no petabyte files, nothing like that, right? So I've spent the last 4 or 5 years there, and I've come across all these opportunities. I think I've been involved in about 60 SDS deals, and what kept jumping out at me is that I don't think that's the right answer, right? I think that the right answer is a distributed file system packaged as SDS, but with one caveat, that file system using NFS is faster than what you guys, or not you guys, but what the traditional world is doing with block. So going back to early days of Auspex, where what they did was they built custom hardware and used Solaris on top of that, and back then that seemed really cool. Until you're in tech support and somebody calls and says like, you have a problem and you have like 4 motherboards in this thing which are custom designed, each one costs $50,000 and you have no tools to troubleshoot that. So you start swapping $50,000 motherboards and then the company goes out of business. So that's what happened to Auspex. So as I've gone down this journey, working with startups and all these companies, working last 4 years in SDS at Scale.io and also at Hedvig, I really just came to the conclusion that these are still tactical, right? So my vision was, look, I think if I look out into the world, what I see is that all the mid-range arrays, some people might not agree with this, but I think that the mid-range arrays are kind of, the high-end arrays have become the mid-range arrays, right? And the mid-range arrays are going to kind of go away, right? So what do I see in my future is I see a lot of flash in the front, right? Multi-tier flash, it could be NVMe, consumer grade, companies figuring out how to do that. That can be packaged in different formats, right? I'm a fan of the scale-out, distributed, commoditized version of that versus the AFAs. And on the back, you're going to have a lot of object. And that may be local object with S3. That may be, porting data to the cloud. And what I mean by the cloud here is like Amazon, Azure, Google. But what I'm seeing is this mid-market appliance idea. The 2-controller system is it's going to be around for a long time, right? It's the dominant thing, but it's going away, right? And so that leads into kind of what would theoretically the next vision of a NAS, scale-out SDS NAS look like? And how do we end up not going down the same, end up in the same pitfalls as the other NAS companies who have not been able to displace NetApp, right? So NetApp is a great product. I've worked there for 8 years as a startup company. All my NetApp friends are all back here, so hi guys. But what if you had a product that would be designed specifically for interacting with S3, with public cloud, which could be faster or as fast as an all-flash array or any flash system, right? What if you could use one protocol to address all of your data sets? I know this is a fantasy that most people don't believe in, but I like the idea. So let me tell you a little something about Elastifile, because you probably haven't heard of Elastifile. Elastifile is founded in end of 2012, 2013. One of the most notable characters on our founding team is Shahar Frank. Shahar Frank was also one of the founders and original CTO for Extreme.io. He's an amazing guy. Actually, I wish he was here to talk. He's a great vision on the market, understands Flash. The engineering team in Israel has, in my opinion anyway, a pool of the highest quality programmers and engineers in the world, and I've seen a lot of engineering teams all over the world. Our corporates in the US are about 100 employees, and we have an interesting model of finance and investors, right? So Battery and Lightspeed are on board with Elastifile. You guys all know Battery and Lightspeed. They're very focused on the storage world. What's interesting about our financing model, and I think this says a lot about what these companies see as the future of strategic technology. Well, there's a bunch of our investors that I can't actually talk about because they haven't announced yet that they're investors in us, and I don't want to break that confidence. Cisco has announced a $15 million investment in Elastifile. Now you'd say, well, why would Cisco be interested? Well, Cisco invests in a lot of companies. It's a hedge. It's maybe an investment for the future. They have their HyperFlex, but again, HyperFlex is also essentially storing VMs, right? It doesn't do file services. It doesn't do file sharing in the way that we would compare that to, example, for NetApp. SanDisk is an investor of ours. We have 6 other very, very large industry giants who have invested between $5 and $10 million in us. So this is an interesting financing model. We're getting most of our financing from our competitors in the market, right? So large server vendors, large SSD vendors, right? Now people ask me, why are all these companies attracted to Elastifile? Why are they investing in Elastifile? And I believe that if you have a scale-out distributed SDS file system which does certain things, which I'll talk about in a second, and you can deliver latency that's about the same as an all-flash array. In other words, what has been the reason that we still are attached to block and fiber channel? Well, very often it's related to the desire to hit low latency. But what if we could hit that same latency in designing a product, in a modern way that would be similar to that performance, right? What if we could do that? And that's kind of, at a very high level, what we're looking at, right? We believe that there is a very, very strong market for consolidation and unification. So I'm going to skip this slide because so we're getting closer. So recent solutions, you guys saw the $4 billion IPO of Nutanix. I was impressed in the sense that the market is willing to invest $4 billion in an HCI company. I think it's a good validation of the market. Let's look at the first generation products, again, all kind of block oriented. As I was out selling a lot of these solutions, half the opportunities I was missing because we just didn't support file services, right? So something to think about. But I don't think we've solved the problem. I don't think anybody here anymore believes that HCI or Nutanix is the final solution, right? It just isn't. It's a silo. It does very specific workloads, does not address file services, does not address what we might consider high performance. It does address something very well, and that's just ease of use and simplicity, right? It's easy to deploy, it works. But the feedback I get from the field is it's too expensive, right? Nobody's complaining that Nutanix is too easy to use, but it's way too expensive, as an example, right? I'm not picking on Nutanix, this is also true for the others. It's still a silo, very limited in scale. Sometimes this is limited by VMware or limited by other things, but the products were not designed for infinite type of scale out. One of the major problems we see is, again, no file sharing, no NAS, no large files, no million files, no cross SMB, NFS access, none of this kind of stuff. And they're relatively point solutions, right? I think we're figuring that out. So where do we think maybe this is, where do I think maybe this is going, right? So, and I used to tell this story when I was at NetApp as well. So there's nothing much different about what I'm saying right here outside of the deployment characteristics I'll talk about in a second. But in general, the prospects, the customers, the people that I talked to over the last 5 years or so, they want something, if possible, that unifies everything, but without the compromise of performance, of negative performance, let's say. And what's really important is that not every company understands exactly what they're going to do with object storage or the cloud. And again, the cloud here, I'm defining that as our public cloud vendors. Let's not get into a discussion about defining that word. It can be used in a lot of different ways. But it's think of cloud as a public vendor, public cloud vendor. You have trends like open source pricing, support only. You have cloud, pay-per-use pricing is a trend that is important to address. You have to be able to interact with the cloud. Can you deploy your solution in the cloud exclusively? Can you deploy it on-premises exclusively? And can we enable that conversion between on-premises and the cloud through offloading data, for example, via S3? That's something that a file system could do because files and objects are very similar and can be transferred between each other. Get rid of kind of HCI silos or fiber channel silos, right? And what does the future look like, right? Maybe it's something over IP. Maybe it's something that uses NFS. Maybe it's something that has a few more protocols to interact with the cloud like S3. Maybe something with SMB for interacting with Microsoft. But that should all work together. Boring, but yes, lower TCO, ease of use, right? But these are all words that you've heard before. And all the buzzwords, agility, scalability, elasticity, right? We use those words, so do a lot of companies, but the point being that you want something that just works, it's simple. Nobody likes storage anymore, right? It's something we have to do, but let's make it so that's not too painful. So here's a little picture. Essentially, what Elastifile delivers as a product is something we call an elastic file system. Okay, so it's a scale-out, distributed, metadata-oriented, balanced file system, very, very unique in its design, completely written from scratch, which provides all the things that you normally associate with SDS, right? So this looks very similar to a lot of my competitors' slides or a lot of the industry slides. The major difference here, again, in the SDS world is that none of the popular SDS solutions are actually a distributed file system leveraging commodity. They are block systems using underlying technologies and consistency algorithms like NoSQL and Cassandra, and they stitch these things together. And all of these solutions as well are designed for hard drives. So they either use caching on the front with SSDs or they use localization to mask the back-end performance issues with hard drives. What we're doing, or where we're going with this, is to be able to have a completely seamless and flowing distributed file system across any number of on-premises or cloud infrastructures, allow you to leverage any of these infrastructures and dynamically flowing workloads. The other point to mention is that if a file system is designed for hard drives, there's two things you can do to increase the performance. You can put it all on flash, and it'll certainly run a little bit faster, or you can cache on flash in front of it, or localize data, for example, the way Nutanix does, and I'm assuming with their acquisition of Pernix that they're also looking into more advanced caching. But what if you built a file system, and there's not too many out there, right? What if you specifically built a file system to work specifically and only with flash? So what if it was multi-tier flash? Writes come in on NVMe, they get staged down to enterprise, staged down to consumer. This is a vision I think that is starting to appear. And the advantage of this is that if I don't have to make any compromise for hard drives, I can get into the NVRAM components of these flash drives. I can get into how does the file system distribute data across all the cells evenly, right? Things that just you cannot align with a file system designed for Hard drives, think about Gluster or Lustre or Ceph or, for that matter, and I don't mean this in a negative way, but the NetApp file system is designed for hard drives. NVRAM was designed to accelerate, that stuff in front. Again, great solution. So, all the normal things that you expect with SDS, you should be able to fail nodes, you should be able to fail SSDs, self-healing, all these kind of things. Now, one thing that I always liked about NetApp in particular was the write anywhere file layout. I think it's a really good idea, right? Why should you write a piece of data, let a disk seek happen and then figure out where to write a piece of data? How about just writing the data wherever the disk head happens to be? It's pretty smart, right? And that worked for a long time. So what if we take that a step further and each disk becomes a node? And what if we start to write anywhere across nodes? Now we may have noisy nodes. We may have interface cards popping up and down. We may have a bad CPU. We may have disks that are not performing. What if we can simply write around those, right? So what if we can write anywhere but on the network, right? So that's kind of what we're thinking about and what we're doing. So we can avoid the noisy neighbors. We can avoid the failing nodes. And we can write simply wherever the data can possibly go, wherever's easiest, whatever's fastest. In supporting an SDS solution that is based on a file system, you have the ability to go to millions, billions of files. You have the ability to scale to thousands of nodes. So in our case, we have not designed some kind of, let's start with 10 nodes and go to 20 nodes. It's been fundamentally designed with metadata striped and balanced very evenly across all SSDs to be able to go to thousands of nodes. Now, I won't say that we've tested thousands of nodes. We've tested hundreds of nodes. But it scales perfectly linearly in terms of IOPS and maintains very, very low latency, again, similar to an all-flash appliance, which is hard to believe, and I'd be happy to show you, if you ping me, I'd be happy to walk you through our presentation and show you our actual performance numbers. Everybody claims big performance numbers. What I'm saying is that it's not uncommon to have big performance nowadays, but it's very useful. There's the idea I like, it's called the abundance of IOPS, right? Now, if I talk to most of you and I say, do you need 1 million IOPS? You'll say, look, I don't need 1 million IOPS. I need like 50,000 IOPS. But if I give you 1 million IOPS for your 50,000 IOPS, guess what? Any performance spike you won't notice. You don't have to plan for performance ever again. And your latency is going to be sub-millisecond like for every IO and every transaction at any load in that realm, right? So no, you don't need 1 million IOPS for every workload, but an abundance of IOPS, abundance of cheap IOPS means that my performance problem is not a problem. I don't have to manage that problem. So scaling up, scaling out, scaling in, scale out is clearly the future. I think we're done with the scale up model in the industry. We can add nodes to increase that performance linear, to shrink it again. Again, these are not new ideas in the SDS world, but again, it's new to do this on a file system, an SDS-based file system. That's what's very unique here. The first generation of SDSs do leverage flash, but again, they leverage it in a way of either localizing data or caching, right? And if I cache 10% of my data, that's cool if I'm only using 10% of that data. But as soon as I get outside of the cache and that cache is not warm, I'm going back to the speeds of the hard drives, which I've seen in practical reality over the last 4 years is problematic, right? There are certain workloads which do well with that, but many don't. So cache or localization is always a way to mask the back-end performance limitations. And it sounds like I'm saying that hard drives are not good, not good at performing. I mean, they're good for streaming workloads or sequential workloads, but not very good for IOPS and low latency. So you do need to mask that to a certain degree. But what if you built a file system that's not designed exclusively for flash, built across many nodes, and is not compromised for hard drives? What you get is something very special. And again, we're still stealthy, and unfortunately, I'm not allowed to show you the numbers, but I can show you in private. If you guys contact me, I'd be very happy to show you, by the way, who our investors are and the performance numbers and all these things. So where I fell in love with Elastifile, and I've always had this kind of love affair with NetApp. I love the company. I love the technology. I love the idea of a file system. If you can build a file system that is faster than block, it raises a real question of what value in your environment does block have. If we can take a file system and design this in a modern infrastructure for Docker, for hypervisors, for consolidating NFS workloads inside of hypervisors, which is something we very rarely do, you can theoretically get to a point of having a unified solution if the performance is good enough. So I don't have to convince you guys why file is maybe interesting. I mean, VMs are files. 50–60% of the world's data growth is file and object. Block storage is still growing linearly, but it's out of its hypergrowth phase. And a majority of the data that's being created in the future will be object and file data. And you guys all know I can run any database and any application over NFS to a file system. Again, the only question really becomes performance. And if we can solve that problem, again, we have something very, very interesting. So, you can use any type of server brands. You see Cisco, one of our investors, lots of, you can run any kind of application if you have an abundance of IOPS and low latency on a file system, as well as running your NAS data sets. And most important in this model is that the idea of offloading, ILM, dynamic tiering is included in the base of the product, right? That this is not something we're trying to figure out how to get it to work in the cloud. This is designed to work in the cloud natively on premises or to put files back and forth, and even subfiles, what we might call blocks or subfiles of VMs. So parts of VMs can be migrated to the cloud and back. Any number of files and policies can be set to manage that. In other words, we're at a point where we kind of can see the future, and we need solutions that are designed to handle this very dynamic infrastructure, this global infrastructure that we're looking at. So the next phase is how do we distribute that? How do we access that around the world? Well, you need some kind of distributed global namespace, which allows you to map anywhere from any type of location. So just to wrap this up, I know I just have a couple of minutes, and I apologize, guys, in advance that I couldn't give you more technical information. This was also a very short session. I appreciate you not throwing things at me. We made an agreement in advance that you wouldn't do that. Normally, I like to give a much more detailed technical presentation, but I'm here, and I'd like to talk to you guys. If you have any, if you have any type of workloads that need a file system or run VMs, and you want sub-millisecond latency scaling into millions of IOPS, there's a few options for you, but I'm convinced that this approach of commodity file system scale out will allow you to hit the IOPS at the lowest price per IOP. Now that's what's important, right? So I can spend $1 million on a set of all-flash arrays and get something very cool, but if I can do that for a quarter of the price and get the same IOPS and the same latency, I have real questions about the AFA market, right? I think it's a good in-between place to be, but I don't think it's the future of storage, right? So I'm out of time. I don't know if there's any questions, guys? Any questions?
Lots, but you won't answer them.
Yeah, unfortunately, I can't answer the hard ones anyway. So, guys, thank you very much. I'm going to be here. Again, I apologize. We have to limit the content today, but I'm happy to share that with you in private through WebExes, through meetings, through phone conversations, through meeting here today. Thank you very much for your attention. I really appreciate it. Thank you very much.